We now begin Chapter 4 in our Odyssey to learn about violent weather and natural hazards. And again, because of the complexity of these concepts, we divided Chapter 4 into two PowerPoints. So this is Chapter 4A PowerPoint. This is going to be all about condensation in the atmosphere. When blobs of air rise from the surface, they expand and the temperature cools, and then condensation occurs and then clouds form. We're going to be discussing in some detail in this chapter the formation of dew, frost, and haze. We're going to talk about foggy weather, which we certainly know a lot about here in the San Joaquin Valley in the wintertime. We're going to talk about how clouds are identified as we look into the sky. How do cloud types get classified, and how do the names get derived? And they're going to see about how clouds are observed from space via satellite imagery. All these things we'll cover in Chapter 4, dealing with condensation in the atmosphere. First off, the formation of dew. Dew, those little blobs of water that form on objects in the early morning hours, the dew forms on objects near the ground surface when those objects cool below the dew point temperature. We talked about the dew point in Chapter 3. That's the temperature to which the air has to fall in order for saturation to occur. So you very commonly in the early morning hours, especially on a clear, calm night, will find dew forming on grass, leaves, highly radiative surfaces like, say, maybe the rooftop of your car, your windshield, and so on. Dew is much more likely on clear nights due to increased radiative cooling. The air near the ground gets coolest, and so that's why dew forms on objects right near the ground, especially if those objects are moist. Like, say, grass. After the dew forms, it can freeze if the temperature drops to below freezing, which leads us to the discussion of frost. That happens when temperature cools below the dew point, and the dew point is below 0 Celsius or 32 Fahrenheit. So that's why in the wintertime, when the dew points are in the teens and 20s, and it's clear at sunset, citrus growers are particularly concerned about freezing weather, which could cause crop damage. In this particular case, water vapor changes to the solid state without going through the liquid state. You remember the three states of matter: gas, liquid, and solid. Well, this is water as gas going directly to water as solid and skipping the liquid phase. This is called deposition. In very dry, cold weather, visible frost may not form, especially the dew points are really low, like in the single digits or teens. You get a freeze, which causes crop damage. Or you get black frost, which describes the condition you get on roadways. It's really not black per se, but what happens is, since the asphalt is black, you really can't see the ice, and that becomes a hazard for motorists. Haze forms when dry condensation nuclei, those are the particles that water molecules cling to in order for clouds to form. When dry condensation nuclei at temperatures above the dew point reflect and scatter sunlight, that tends to create kind of a bluish haze. Wet condensation nuclei, when the relative humidity is 75% or higher, reflect and scatter light, and that creates that grayish or whitish haze that we sometimes see after the fog breaks up in the wintertime. Again, what are condensation nuclei? They are the solid particles in the air, dust, sea salt, soot, whatever, that water molecules cling to in order for condensation to occur and in order for clouds to form. And then there's fog, which of course we're quite familiar with here in the wintertime in the valley. Fog forms when those haze particles grow larger as the relative humidity approaches 100%. They grow larger because more water molecules are condensing on the condensation nuclei. The increasing size and concentration of water droplets then reduce the visibility, horizontal visibility, to less than a kilometer. And that haze becomes a thicker cloud resting near the ground. Fog can form either by cooling of the air or via evaporation and mixing of the air. The picture at right actually comes from a different chapter, but it shows you the example of the formation of ground fog or radiation fog, which of course is very common on winter mornings here in the San Joaquin Valley. So now we're going to talk about different kinds of fog. One type of fog that is caused by cooling is called radiation fog. The ideal conditions for the formation of radiation fog are as follows. If you have a clear, cool night with moist soil or grass, very stable air, and calm to very light winds, so that the temperatures right above the dirt or the grass are the coldest. The temperature rapidly falls to the dew point just above the ground surface, and then voila, the fog forms. And of course, if that fog persists for many, many days in the wintertime and you don't get much sunlight, then we have a local name for that. We call it tule fog because it seems to emanate from the marshes and the riverbeds here in the Central Valley. This is a visible satellite image from November 20th, 2002. It comes from your textbook. This is a satellite view of fog which was observed in the San Joaquin Valley on that morning. You see a gap there that goes over to the foothills to the east, and then you see the snow-capped Sierra even farther to the east. On this particular morning, people driving too fast for conditions, in other words, low visibilities occurred, did cause a 14-car pileup near Fresno on this morning, November 20th, 2002. You see those newspaper headlines, fog blamed for accident. No, it's not the fog that's blamed on accident. It's people driving 70 miles an hour when they can't see more than 100 yards. That's what causes accidents in the fog. Now, another fog that's formed by cooling is called advection fog. If you go to the coast in the summertime, you're very familiar with this. You know, the old coastal forecast in the summer when you want to get out of the valley heat. Fog and low clouds nights and mornings leading to afternoon sun, highs in the 60s by the ocean, 70s and 80s inland. I'm sure you've all heard that refrain in the summer when you're checking the coastal forecast. Well, that's advection fog, and it forms when warm, moist air moves over a sufficiently colder surface, i.e. the Pacific Ocean, which causes the moist air to cool to its saturation point. This is really common along the California coast in spring and summer, as the warm, moist air from the Pacific Ocean is advected, meaning transported horizontally, by westerly winds over the colder coastal waters. The ocean water temperatures in spring and early summer along the California coast are quite cold, as you no doubt know, if you have gone to the beach and you put your toes in that water. It's not exactly tropical. That's because of that cold ocean current we discussed in the previous chapter that comes down from the Gulf of Alaska, called the California Current. This graphic shows you a little comparison of how radiation fog forms compared to how advection fog forms. And they are two different methods, but in each case, these two kinds of fog are formed by the cooling of air to the dew point, allowing the fog to form. Then there's a kind of fog that's called upslope fog, which basically means you get a moist, cool air mass that is lifted as it is slammed up against the slopes of a mountain range along, say, an elevated plain or a hill. This is very common on the high plains of the central United States, just east of the Rockies, and along the eastern slopes of the Rocky Mountains. There, they don't even call it upslope. Sometimes they call it upslop, because what happens is, with those clouds being forced to rise against the eastern slopes of the Rockies from the Great Plains, you can get freezing drizzle or freezing rain or even snow sometimes. This often occurs here in California on the windward slopes of the mountain ranges, like the, say, the western slopes of the Sierra Nevada or the northern slopes of the Tehachapi Mountains. For instance, if you've driven on I-5 south of Bakersfield, you're going to LA over the Grapevine, and it's clear over the valley, and then you start climbing that hill past the CHP Grapevine station there, and you get enveloped in that fog. Well, that's upslope fog, as a cool, moist air mass is lifted by the mountain slopes. Then there's another kind of fog that's caused by evaporation or mixing of the air, and we call this evaporation fog or mixing fog. This is when warm, moist air meets cold air and it mixes with it. If you've ever gone camping in the mountains in the summertime on a clear, cool morning at daybreak, you see this, because what happens is that the temperature of the surface of the water on a lake is much warmer than the air itself, and so you get what's called steam fog that forms. This is when you see your breath on a cold morning, or if you went to a high school with a swimming complex and you walk by on a winter morning a heated swimming pool and you see that steam fog rising from it. These are examples of steam fog, and this picture is actually taken from a different weather textbook from a book called The Atmosphere by Lutkins and Tarbuck. It's the 12th edition, Pearson Education. Now, let's talk about the dangers of foggy weather. Again, you see these newspaper headlines, fog blamed on accident. Once again, it's people driving too fast in the fog that really are blamed on the accident. Obviously, coastal areas and higher elevations are more fog-prone areas, if you look at figure 4.9 on page 101. Reduced visibility. People driving too fast for conditions can cause huge car pileups. We hear about that from time to time here in the Central Valley and also on the Gulf Coast of the United States. 22% of the weather-related deaths in aviation are caused by reduced visibility due to fog. Now, that doesn't mean flying is unsafe. It's the safest form of transportation we have. But reduced visibility does cause aircraft mishaps from time to time. And when you have a lot of fog with very stable air, they can also play a role in poor air quality, leading to smog, such as the killer smog in London in December 1952. There is a special interest box in your textbook addressing that issue. Now we're going to go to how clouds are classified and identified from your perspective as a human being on the surface of the earth looking upward toward the sky. I hope that after you take this course that you'll never look at the sky the same way again. That's my goal, is to get you to look at the sky and to never think of it trivially, but actually say, oh yeah, Boyd told me about that. That's a cumulus cloud. Anyway, I digress. This is a generalized illustration of the basic cloud types. They're classified by how high the base of the cloud is above the ground and the form they take or their shape. I'm going to present this information opposite of the textbook, which goes high clouds, middle clouds, low clouds. I'm going to go low clouds, middle clouds, high clouds. It makes more sense to me because, after all, we are standing down here on the surface and then we ascend upwards, say in a hot air balloon or an aircraft or something. So we're going to talk about low clouds. We already covered fog. Middle clouds, and then high clouds, and then the clouds of vertical development. That'll be in PowerPoint 4B. The classification of clouds with respect to their names, these are from Latin names. There was a guy named Luke Howard in the early 1800s who was a British naturalist who devised this cloud classification system that still survives 200 years later. We classify clouds by their height above ground level and their shape and appearance. So we'll start with the low clouds first, and these are the stratus clouds. There are nimbostratus clouds, which are dark and gray and produce precipitation. Sometimes you see lower, fast-moving clouds below the nimbus clouds that produce the rain, the nimbostratus clouds. Those are called stratusfractus or scud. Then there are stratocumulus clouds, which are low and lumpy, and they appear in patches with blue sky in between. The color ranges from light to dark gray. That's stratocumulus clouds. Here's a nice picture of stratus clouds. I took this picture in the Wicklow Hills south of the city of Dublin in the Republic of Ireland several years ago. It's a uniform grayish cloud like a fog that doesn't reach the ground. If a thick fog layer on the surface lifts up from the surface, it can turn into a layer of stratus clouds, and that's very common in the winter here in the San Joaquin Valley. Normally you don't get any precipitation out of stratus clouds, but occasionally you can get a light mist or a drizzle that may fall out of them. Now we're up to the middle clouds. They're basically two types. There's altocumulus, which is the top photograph. They're gray, sort of puffy masses in parallel waves or bands. Often one part of the cloud is darker than the other. They make for very pretty sunrises and sunsets. And then there are altostratus clouds, which are bluish gray cloud masses. You can't really distinguish individual cloud masses with very few breaks. This can be a sign that nimbostratus clouds may form or move in shortly, which could be kind of a sign that rain or snow may be on the way. And then we get to the high clouds, which are the high, thin, wispy cirrus clouds. And usually, when you get to the altitude of these clouds, the clouds are made up of ice crystals and are rather thin, as opposed to water droplets. These are thin, wispy clouds made out of ice crystals, the cirrus clouds, with breaks of blue sky in between. And because of their shape and their form, they're often referred to as mare's tails, like the tail of a horse. And then there are cirrocumulus clouds, which are a lot like altocumulus clouds, but they're a lot less frequent because they're a combination of water droplets and ice crystals at that altitude, say up around 20,000 feet above ground level. They're small, rounded white puffs that may occur individually or in long rows. In the cirrostratus, you can't really determine individual elements of clouds. There are thick sheets of cirrus clouds. The sun and the moon are dimly visible, and the ice crystals in these clouds, if the sun is at the proper angle, can actually bend the light that passes through them, which produces a halo, say around the full moon at night, or even during the day with the sun. This ends Chapter 4A PowerPoint.